Hello everyone, hope all of you are doing great. And in today's video, we are going to discuss Workbook Lesson 3.1, which is all about multiplying and dividing by powers of 10. So, before we start, I just would like to remind you that in multiplication by powers of 10, for example, if I'm multiplying by 10 to the power of 3, that means you're going to move the decimal point to the right. Move the decimal point to the right. How many digits is three digits to the right? Okay, good. But if I'm dividing by 10 to the power of 3, it means that I'm going to move the decimal point to the left. How many digits? Also the same thing, three digits to the left. Three digits to the left. Okay, but if I'm multiplying by 10 to the power of negative 3, we're going to do the opposite. Mister, multiplying by 10 to the power of 3, move the decimal point to the right. Yes, but if the power is negative, move the decimal point to the left. Same thing in division. In division, Mister, usually we learned ever since we were in year 6 that we move the decimal point to the left in division. That is great, and this is absolutely right. But if you are dividing by 10 to the power of negative 3, for example, or negative power, no matter what the number that is here written is, as long as it's negative, I'm going to do the opposite of what's normal. Normally, we just move it to the left, but it's negative power. We're going to move it to the right. Let's practice this and just to consolidate this piece of information. Here, just warming up, they are telling you here that 3.4 times 10 to the power of 2, it is the same as multiplying it by 100, which is going to be 340. And here it is, I moved it two digits to the right. Just one digit to the right is 34. I need one more digit, so 340. Same thing over here, but this is multiplying by 1000, which is the same as 4800. I need to move the decimal point of three digits to the right. I have only one digit here, so I need two more. So I need two more zeros. Multiplying by 10 to the power of 1 is just 10. Moving the decimal point one digit to the right is 125. And so on. This here means 100,000 because it has five zeros, which means 500,000. This one here is 1,000, which simply means 14,000. Match each rectangular card with the correct oval card. So here, multiplying it by 10 to the power of negative 1. That is the same as, Mister, you said if I'm multiplying it by negative power, it means I'm going to move it to the left as if I'm dividing. So multiplying it by 10 to the power of negative 1 is the same as dividing it by 10 to the power of 1. So this is I. Multiplying by 10 to the power of negative 2 is the same as if you're dividing by 10 to the power of 2. So it is dividing by 100. So this is V. Divided by 10 to the power of 2 or divided by 100. This one is divided by 10 to the power of 3. Either 10 to the power of 3. I don't have 10 to the power of 3. Yes, but I have divided by 1000. It's here, this one. So here I go I. V. So again, this is IV, this is V, this is I. All right, next. 10 times, multiplying by 10 to the power of negative 4. Mister, this is the same as dividing by 10 to the power of 4, which is dividing by four zeros. That's a 10,000. Exactly. So it is 10,000 is I. Just I. Multiplying by 10 to the power of negative 5 is the same as dividing by 10 to the power of 5, which is five zeros, which is triple I. Next, here you are multiplying by 10 to the power of negative 2 as if you're dividing by 10 to the power of 2, which is dividing by 100, which is moving the decimal point to two digits to the left, 0.034. Here, multiplying 10 to the power of negative 3 as if you're dividing by 10 to the power of 3, which means dividing by 1000. gonna lead to 0.008. All right, then you've got here divided by 10 to the power of 4, which is 4 zeros, which is going to be 0.0015. Here, you are multiplying by 10 to the power of negative 1 as if you're dividing by 10 to the power of 1, which is dividing just by 10, 1.2. Work out 28 times 10 to the power of 2, just simply like what we've done over there. This is going to be 2800. Here, I'm going to multiply it by 10 to the power of 3. So you move it 3 digits to the right. It's 2880. 3 digits to the right. Multiplying by 10 to the power of 0, that is as what's anything to the power of 0? We took it in lesson 1.3, which is about the indices. We took it in lesson 2.3 as well in algebra. Multiplying by anything multiplied by 10 by anything to the power of 0 is equal to 1. So this is 28 times 1, which is just 28. Multiplying by a negative power, it means you're dividing by 10 to the power of 4. So 4 digits to the left, I'm going to move it. So it's 0.2800. And so on with the rest of the questions. You're going to have the answer key. You already have the answer key in there. Just explain to you here this section. The second section here says to you, you're dividing by 10. Mister, I'm going to move the decimal point once to the left. Move the decimal point here 4 digits to the left. Move the decimal point here. Oh, no, mister, that's dividing by 1. 10 to the power of 0 is 1. Oh, anything divided by 1 is just the same thing. Here, I'm going to move it to mister 4 digits to the left. Oh, it is negative 4. So you do the opposite as if you're multiplying by 10 to the power of 4. So it is 304. That now I move the 2 digits to the right. I need 2 more digits to the right. So it's 30,400. Why did I do this? Because it's divided by negative power as if you're multiplying by that positive power. So it's times 10 to the power of 4. And so on with the rest of the questions. Nothing is different at all. You're going to have the answer key over there. The only thing that requires concentration and a lot of focus is just only the number of times you're going to move the decimal point. So for example, here, I'm going to move it 4 digits to the right. Mister, it is already 430. I need to move it 4 digits to the right. It is a mister to the left. If it was positive power, I would have moved it to the left, but it is negative power, so I'm going to move it to the right. Moving it to the right, I have 1, 2, 3 digits. Okay, but I need one more, so it is 340. And definitely the 0 is unneeded. Same thing exactly with the rest of the question. Here, they want you to work out the answers to the calculations in the code box. Where is the code box? It is down here. So they want you to find over here. A, the saying is 500 divided by 10 to the power of 0. So what is 500 divided by 10 to the power of 0? A, for example, the saying 500 divided by 10 to the power of 0. Mister, we know that 10 to the power of 0 is 1, so it is 500 divided by 1, which is just 500. So I'm going to look for 500, and then I put letter A above it, and so on with the rest of the questions. So for example, the second one as well, 0.05 divided by 10 to the power of negative 1, or negative power, it means as if you're multiplying by 10 to the power of 1. So it is I'm going to move the decimal point 1 digit to the right. So it becomes 0.5. So 0.5 is F. I'm going to go up there, look for 0.5. It's here, and I write F. What do I do after that? You keep going with the rest of the questions down there, and you put the letters up here in the box until you find that the final one, what was it? Uh, Here, what I remember was the word math. You can find everything in the answer key as well. Multiplication of 10. Yes, I guess. Oh, 1 second, I'm opening it here. You got 7. Powers of 10. Easy. You're gonna find powers of 10. Weird. E. Easy, not math. I forgot the code. I read it just only a few minutes ago. E. Z. So powers of 10 easy. This is the code. Definitely gonna find out about it only after you answer each one of them and you put each answer, each letter in the right position up there. Work out 5 times 10 to the power of 3. The same thing exactly. You're multiplying 5 by 1,000, so it's 5,000. And here it is 500. And here is just 50. While here is just 5. And here is zero point 0.5 because you're going to divide by 10. And here 0.05 because you're going to divide by 100. All right. When you multiply a number by 10 to the power of negative 4, is the answer larger, smaller than, or smaller than when you multiply by the power of negative 10 to the power of negative 5? You're multiplying, compare the powers. Look at that. Which one is larger? 10 to the power of negative 4, well, or 10 to the power of negative 5. You need to just look at this. Look at the power. This power is larger than this power, then definitely it is going to be, this one is going to give me a larger answer. So 10 to the power of negative 4 is larger. How do I know? Well, they're asking you to look at the questions, your answers to part A. Look at that, answers to part A. Which one is larger? An answer of V or answer of VI? When I multiplied by 10 to the power of negative 1, or when I multiplied by 10 to the power of negative 2 is larger? Yes, when I multiply by 10 to the power of negative 1 is larger than when I multiply by 10 to the power of negative 2. 0.5 is larger than 0.05. So, because the power is larger, negative 1 is greater than negative 2. So, definitely the answer of negative 1 to the power of negative 1 is greater than the answer of 10 to the power of negative 2. Here, work out this. We're going to divide. Dividing by 1,000, so it's going to be 0.099. This one over here is dividing by 100, 0.99. This is divided by 10, so 9.9. Divided by 1, which is 99. Divided by, oh no, mister, here as if you're multiplying by 10 to the power of 1. Multiplying by 10 to the power of 1, it means multiplying by 10, which is 990. Here, as if you're multiplying by 10 to the power of 2. So it's going to be 9900. And they are asking you, do you think in division this one is larger, 10 to the power of negative 4, or this is going to give you a larger answer, 10 to the power of negative 5? Looking at the questions up there, if the power in division is smaller, which means here negative 1 and negative 2, which one is smaller? Negative 2 is smaller. Then the answer is going to get larger. Again, in multiplication, the power gets smaller, the answer gets smaller. In division, the power gets smaller, the answer gets bigger. You can repeat this part of the video, write it down on a piece of paper. It will make sense to you once you write it down. Again, when the power in multiplication gets smaller, the answer gets smaller. If the power in division gets smaller, the answer gets bigger, and the opposite. All right, let's continue. Here, multiplying 0.04 by 10 to the power of what gives you 4? You're going to find, Mister, I need 1, 2, 3 digits to the right. So it is to the power of 3. I'm going to use here thin. So it is to the power of 3. Let's make it red. All right. Here, 4 times what? 10 to the power of what is 4? 4 times 10 to the power of 0. Here, times 10 to the power of 1 is going to move it 1 digit to the left. I think I need to make it thicker. 1. Here, 40 divided by 10 to the power of 1 is going to make it 4. Here, divided by 10 to the power... Oh, mister, 1 second. Division takes it to the left. But I need it to become 4, so I need to move it to the right. Oh, so it's negative. But how many digits to the right? Digits to the right. 2 digits to the right, so to the power of negative 2. Here, I need to move it and move it to the left, so it's positive. But 2 digits to the left so that it becomes 4, so it is to the power of 2. Same technique exactly over here, but it's 0.67. So here I'm going to need to move it 2 digits to the left, 10 to the power of 2. Here I need to move it 1, 2 digits, 3 digits to the left, so 10 to the power of 3. I need to move it 1 digit to the left, so it's 10 to the power of 1. 1 digit to the left. Oh, sorry, that's multiplication. So here I need to move it 1 digit to the left in multiplication, then it is negative 1. 10 to the power of negative 1. This way I move it 1 digit to the left. Here I need to move it 1 digit, 2 digits to the left, so I need this to be negative 2 because it's multiplication. Here I need it 1 digit to the left, so it's 10 to the power of 1. Here I need to move it 1, 2, 3 digits to the left. It's multiplication, so negative 3. The last page. Sort these cards into groups that give the same value. Well, after answering this just exactly like what we've done in the previous pages, you're going to find that A, D, and H, they have the same answer exactly, which is all of them are going to be 40. That's A, D, and H, 40, 40. And what about B, E, and J? B, E, and J, I'm going to use the color green. B, E, and J, all of them are going to be 0.45. The green is going to be 0.45. All right? 1 second. Here we've got B is going to be here. 1, 2, 3, 4 is going to become 4.5. E is going to become 1, 2, 3 is also 4.5. While the last one is going to become, oh, sorry, it is, yes, 4.5. My bad. It is not 10 to the, it's not 1. I thought that this is 10 to the power of 0, which is going to keep it the same. It's 10 to the power of 1. I'm going to move it 1 digit to the left, to the right. So 4.5 also. So B, E, and J is 4.5. The last group is going to be G, C, and I. And here, all of them, the 3 of them, are going to be also the same exactly, which is going to be equal to 0.45. This is going to be also 0.45. This one is multiplied by 10 to the power of 0, which is multiplied by 1. So it's going to be 0.45. And the last one here is also 0.45. Which card is going to have a different value? They're telling you here there is one card's pair, right? 2 other cards that give the same value as this card. So this is a spare card. 4.5 times 10 to the power of negative 2 is going to give you, let's choose a different color. Let's make it blue. This one here is going to give you 0.045. They want you to write 2 more cards that give you the same answer. There are multiple of cards that can give you the same answer. For example, if I say to you 45 divided by 10 to the power of 3, that's going to give you 0.045. If you write, for example, 0.0045 multiplied by 10 to the power of 1, which is just multiplied by 10, that's going to make it 0.045 as well. So this can be a card multiplied by 10 to the power of 1. This is going to be another card, and both of them we give the same value as f. Put a tick for the numbers that are not written in the standard form. If you remember, the standard form is any number that is between 1 and 10 multiplied by 10 to the power of any integer. All right, Mister, all of them are multiplied by 10 to the power of any integer. All of them, 10 to the power of 3, 10 to the power of negative 2, and so on till the end. But here, I don't have all of them between 1 and 10. This one is a standard form, yes. This one is standard form, yes, between 1 and 10. This one is standard form, no, it's not between 1 and 10. This one is not between 1 and 10. This one is between 1 and 10. This one is not between 1 and 10. All right, so these numbers are written in a standard form. Write each number as a normal number. So you just multiply normally. Multiplied by 100 is 270. Multiplied by 10 to the power of negative 3 as if you're dividing by 1000, so 0.0048. All right, here you multiply by 10 to the power of 5 is going to be 125, 3 zeros. Write whether A, B, or C is the correct standard form for form number for each measurement or not. They want here 11,000 in the standard form. I needed a master to be 1.1, so it is 1.1, all of them, good, times 10 to the power of, I need to move it here. How many digits? 1, 2, 3, 4. So 4 digits to the left, it is 10 to the power of 4. If you multiply 1.1 by 10 to the power of 4, it's going to give you exactly 11,000. And here, I'm going to move it 3 digits to the left. Nope, 5 digits to the left. If you multiply it by 10 to the power of 5, this number, 3.84 multiplied by 10 to the power of 5 is going to give you 384,000. Here, I'm going to move it 3, 6, 8 digits to the left. So it is multiplied by 10 to the power of 8. If you multiply it, the normal or the ordinary number is going to be equivalent to 150 million. The length of a plant cell is approximately this. Make it into standard form. It needs to be between 1 and 10. Done, yeah, Mr. 555. But one of them only is correct. I'm going to move the decimal point 1, 2, 3, 4, 5 digits to the right. So it is multiplied by 10 to the power of negative 5. And that's it. This is all about lesson 2. It's actually 3.1. Thank you so much everyone for watching and see you in another video.